Let's prove this inequality. The question is, prove that for all x greater than 1, 2 square root of x is greater than 3 minus 1 over x. So how do we do this? Let's use the AMGM inequality to prove this. So let's say when you have two terms, let's say a and b. A plus b divided by 2, right? That's the average. Is greater than or equal to the square root of the product of these two terms. So a times b. Now, if it has two terms, this is the inequality. If it has three terms, let's say a plus b plus c, three terms. The average of these three terms would be to divide by 3. And it's greater than or equal to the cube root of the product of these three terms, a, b, c. Okay, in this question, we will have three terms here. So I'm going to break down 2 times square root of x into two terms. So here, 2 times square root of x is the same as square root of x plus square root of x. Now I have three terms. 1, 2, and 3. I'm talking about all the terms with the variable x. Okay, now let's apply this inequality here. So now let's let a equals to, right? A equals to this square root of x. And then b equals to this square root of x. And then c equal to this term, 1 over x. Now, here, this side will be square root of x plus square root of x plus 1 over x, all divided by 3. That's the average of these three terms on this side. Now, on the right side, the cube root of the product of these three terms now will be greater than or equal to the cube root of the product of these three terms. That will be square root of x times square root of x times 1 over x. Okay. Now on the left side, square root of x plus square root of x is 2 times square root of x plus 1 over x, all divided by 3. Now it's greater than or equal to, now on this side, square root of x times square root of x is just x. Now x times 1 is x. X over x is 1. So we have cube root of 1. Now, cube root of 1 is just equal to 1. So we have 2 square root of x plus 1 over square root of x, all divided by 3 is greater than or equal to 1. Okay, now multiply both sides by 3. 2 square root of x plus 1 over x is greater than or equal to 3. Now, subtract 1 over x from both sides. We have 2 square root of x is greater than or equal to 3 minus 1 over x. Now, this looks like this, right? The original question. However, in the original question, it's only greater than. What we just did here has the equal sign here too. So it's greater than or equal to. So what happened here? Notice that when x is equal to 1, then you have 2 square root of x equals to 2 times square root of 1 is equal to 2 times 1, that's equal to 2, right? Now, on this side, 3 minus 1 over x is equal to 3 minus 1 over 1. That's equal to 3 minus 1. That's equal to 2. Okay, so they both are equal to 2. That means when x is equal to 1, 2 square root of x is equal to 3 minus 1 over x. So that's where the equal sign comes from. Okay, now notice that x here under the square root cannot be negative. We're not talking about complex number here. So in this case, x cannot be negative. X cannot be less than 0 in square root of x. Then x has to be greater than or equal to 1. Now, since when x is equal to 1, we have 2 times square root of x equals to 3 minus 1 over x. Then when x is greater than 1, we will have 2 times square root of x is greater than 3 minus 1 over x. Because here, right, you only have 2 times square root of x greater than or equal to 3 minus 1 over x. If when x is equal to 1, these two are equal, then when x is greater than 1, 2 times square root of x must be greater than 3 minus 1 over x. So this proves what is asked in the question here. When x is greater than 1, 2 times square root of x is greater than 3 minus 1 over x. Okay, so that is the proof. But let's look at from the calculus perspective. So let's look at it when we use derivative. Okay, using derivative. Okay, so for the first function, now let's say derivative of 2 square root of x. That's the same as derivative of 2 times x to the power 1 over 2. And that would be, bring the power to the front, 1 over 2 times 2 times x to the power of 1 over 2 minus 1 to the power, right? And that is, now 2 and 2 cancel out, you have x to the power of negative 1 over 2. And that is equal to 1 over square root of x. Okay, now derivative of the right side of the function, 3 minus 1 over x. That is the same as derivative of 3 minus x to the power of negative 1. And we know that, right? Derivative of a constant is 0, so 0 minus, now move the power to the front, negative 1 times x to the power of negative 1 minus 1 to the power. So here we have minus is positive. That is 1 over x squared. Okay, so now let's compare these two. Now again, x here is under the square root. So we have to say that x cannot be negative. So x cannot be less than 0, right? In square root of x. So again, x has to be greater than or equal to 1. Okay. Now, here. Let's remember these two here. Now, since x has to be greater than or equal to 1, when x is equal to 1, what do we have? So we have 1 over square root of x is equal to 1 over square root of 1. That's equal to 1 over 1, which is equal to 1. And then here, 1 over x squared is equal to 1 over 1 squared. That's equal to 1 over 1, which is equal to 1. So that means when x is equal to 1, 1 over square root of x is equal to 1 over x squared. Okay, now what happens when x is greater than 1? In this case, 1 over square root of x will be greater than 1 over x squared. Why? Because let's say when x is greater than 1, right? So let's say 2 here, right? 1 over square root of 2 has to be greater than 1 over 2 squared, because 2 squared is 4. When you divide something by a smaller number, the value is bigger. When you divide something by a larger number, the value will be smaller, because the numerator, both numerators are 1, right? So if the denominator is smaller, the value is larger. If the denominator is larger, the value is smaller. So 1 over square root of x must be greater than 1 over x squared when x is greater than 1. Now we also know that here 2 times square root of x and 3 minus 1 over x intersect at x equal to 1, right? Because they have equal value when x is equal to 1. But since this is the derivative, right, of these two functions, so this is the derivative of 2 times square root of x, and this is the derivative of 3 minus 1 over x, right? The derivative of a function gives you the slope of the tangent line at the x value. So that means when x is greater than 1, the slope of the tangent line to 2 times square root of x is steeper than the slope of the tangent line to 3 minus 1 over x. Okay, now let me sketch the graph. So let's say here. That would be 2 times square root of x. Okay. Now next. So this would be 3 minus 1 over x. Over here, they intersect at x equal to 1. So as you can see, right, the slope of the tangent line to 2 times square root of x is steeper than the slope of the tangent line to 3 minus 1 over x after x equal to 1. Basically, on this portion, from here on, x is greater than 1, right? So as you can see, the value of 2 times square root of x is larger than the value of 3 minus 1 over x. If this is a graph, right, you look at the y value here, okay? So the y value here is larger than the y value here. So that's how you can see it as well. That's how you can prove this as well. Hope you enjoyed this video. Don't forget to subscribe to my channel. Thank you.